respiratory therapist role in acid-base balance, maintenance of oxygen and or acid-base balance is what respiratory care is all about. A respiratory therapist who is skilled in this area is capable of properly assessing and following the patient's acid-base, oxygenation, and ventilatory status. As respiratory care practitioners, your job is much more than drawing, analyzing, and assessing blood gases. It is also comfort the patient, assist the physician, monitor the patient, and assure the proper treatment. What is acid-base balance? Human body operates in a narrow pH range. So the normal range of pH is 7.35 to 7.45. It is known to be acidotic if it is less than 7.35. Again, if it is less than 7.35, it is acidotic. And in cases which is above 7.45, it is considered to be alkalosis or alkalotic. Balance is dependent on the reduction of carbon dioxide in the blood. There are two systems to regulate this balance. We have in respiratory, we have the carbon dioxide regulated by the lungs via ventilation, and metabolic or bicarbonate regulated by the kidneys via excretion in urine. One system is balanced by the other. So it is like a seesaw or an equilibrium that the body maintains its normal homeostasis that compensate the balance of this acid-base balance. So the blood gases show the status of this balance and can be determined system imbalances via ABG result. So the pH or the puissance of hydrogen concentration, so it's defined as the small letter P with a capital letter H, that is pH, or the puissance of hydrogen concentration, is the measurement used to express the hydrogen ion activity. Is mathematically defined as the negative logarithm of the hydrogen ion activity. So on the earlier discussion, I have sent you the introduction pertains to the log of pH is equals to negative log close and open parenthesis of hydrogen concentration. Normal body pH is slightly alkaline and normal range of 7.35 to 7.45. The pH range of the body maintains is very narrow and dependent on the relationship between the acid, bases, and buffer. So these acid, bases, and buffer are, like for example, acids is a substance that donate the free hydrogen ions. A pH value of negative 7.0 is considered acidic. We have the bases, substances that removes the hydrogen ion from the solution. A pH value of more than 7.0 is alkaline. Buffers, weak acid or weak bases that accept or donate hydrogen ions to prevent wide fluctuation of pH in the body so that the normal metabolism can be continued. The most important buffer system in the body is called the bicarbonate carbonic acid. Again, bicarbonate / carbonic acid system, or commonly known as the Henderson-Hasselbalch equation. Please review the earlier overview of this subject I have sent to you via files on the early part of our lesson. As continuity, the most important buffer system in the body, as I mentioned earlier, is the bicarbonate over carbonic acid system. The second is the hemoglobin system, and the third is the serum protein buffer system. So what are the most important components So the pH is dependent upon the relationship between the bicarbonate, considered the metabolic component, and the PCO2, or partial pressure of the carbon dioxide in arterial level, or PCO2, considered to be the respiratory component. The metabolic and respiratory components are constantly fluctuating and changing to balance each other to maintain the pH at which the body best maintains itself. So, to focus on respiratory component, 1 is regulated by the lungs by either increasing the ventilation to remove carbon dioxide, or this states what we call the hyperventilation mechanism. So dapat the body tends to hyperventilate to remove the carbon dioxide in the system, or by decreasing the ventilation to retain carbon dioxide. When it means retain or to slow down ventilation or decreasing the ventilation, that is the state of hypoventilation. So the body tends to regulate the retention of carbon dioxide. Second is we have the metabolic component. The metabolic component is primarily regulated by the kidneys, which controls the amount of circulating the hydrogen ions and bicarbonate. A fairly slow process pertains to metabolic components. Metabolic components seems to be the mechanism for removal of non-volatile acids such as dietary acids, lactic acids, and keto acids.